A lot of students still don't understand the fundamentals of intermolecular bonding. And why do I know? Because only 20% of students got this question right. Let me show you. So here you have a question where you've got 3 different organic compounds, all of the same molecular mass, and you have to try and figure out or guesstimate what the boiling point of Z is, and you've got all of these options on the left-hand side. Now you'll notice, as I mentioned, all of the molecular masses are the same, so you know that the size and the mass isn't going to play a part in the difference in the boiling point. It's purely going to be the type of intermolecular bonding that's going to occur between the same molecules, so between X's, between Y's, and between Z's. What I want you to focus on is these areas that I've marked in blue. So for X, you can see the hydroxyl group, the OH. Now you know that with the hydroxyl group you can form, if another one of those butanols comes along, it'll form hydrogen bonds with the other butanol molecule. The second molecule here, you can see the carboxyl group. Now the carboxyl group is really interesting because another one of those carboxyls comes together, so ethanoic acid will come, it will actually form what's called a dimer. So it can actually hydrogen bond, but at 2 different spots, so the OH and also the COO part. So it makes it for a really strong bond. And then you see for third, you can see that it's an ester. Now, unlike the other 2, X and Y, the ester can only really form dipole-dipole interactions. So let's just kind of summarize that. So if you remember in terms of the strengths of the intermolecular bonds, you know that hydrogen bonding is the strongest, followed by dipole and dispersion. Now, the thing that you need to understand is that we've acknowledged that all molecules have dispersion forces, but in this instance, in terms of the main forces that dictate the boiling point here, it's more around the hydrogen bonding and the dipole-dipole interactions. So you can see here, with the dipole-dipole interaction versus the hydrogen bonding, we know that that's going to have it's a weaker bond, which means it's going to take less energy to pull those molecules apart. Therefore, the boiling point is going to be lower than both 97 and 118, because we know that the hydrogen bonds are stronger. And you can also see here it's reflected in Y having the highest boiling point. Those dimers are actually quite strong. The hydrogen bonds, the 2 that can form between carboxyl groups, it's quite strong. So you can see that it takes much more energy to actually break the bonds, and therefore it has a higher boiling point. So it'll go Y, X, and then Z. Now, if we have a look here, the only option that actually falls below both X and Y is option A.